So basically, we have last time, no? This is our lesson right now. This is what, chapter 9? So we are now in chapter 9, no? So we have actually chapters 10, 11, 12. I think chapter 10 is interference and diffraction. Chapter 11 is relativity. Chapter 12 is nuclear physics. And these remaining chapters, however, now the three remaining chapters, I am not really sure, no, if we will really have the time to exhaust that, no. And if ever we will try to uh, cover it, no. And again, no, so the remaining lesson will be this chapter 9, no? And I've mentioned about the other three chapters that are still left, but most likely, no, will not be covered um, anymore, no, or exhaustively, no. So going to this, no, so we mentioned about geometric optics, which literally, no, studies about images, no, the thing that we see, no, behind our mirror, no, and then even actually, no, when we look at our camera, no, we see somebody else there also, no. But one good thing about our camera, if you raise your right hand, no, then the right hand of the other guy there, no, is the right hand, no, unless of course you flip the camera that you have, no. But in the mirror, in a plane mirror, when you raise your right hand, the left hand, no, is being raised some other person sa pihak, no. So it's literally, no, I think, no, they call it as a perverted image, no. Kay, again, no, the right and the left hands are, no, hindi siya parehas ang camera nga ginagamit natin, no. But nonetheless, no, we have the geometric optics that focuses on the images created by plane mirrors, spherical mirrors, no, and maybe lenses, no. And our focus of going into its math, no, maybe, no, we may not, no, give it, no, a lot of focus also because of the brevity of time. And especially this week is CEW week, no. So we have light. One principle that we know, light, no, is covered by photons, and this traveling light travels in a straight line, no? So these are crucial idea, no? So when they bounce, they also follow a straight path, no? And when they cross each other, when they kind of meet, no, so if they are cars, then they will bump into each other, but you'll notice that when they bump into each other, then they will move in a different direction, but not for light, no? So if you let light cross, then they will simply, no, um, pass each other, no, but I think, no, they will not interfere with the path of each of the ray of light, no? So that's one thing about light, no. Next, they follow reflection, refraction, no? And again, no, the main thing about this lesson is on the images that are formed, no, when we sketch the path of reflection, no, reflected ray, with regards to you or any object in front of the mirror, no? I think we also now make mention about the kinds of mirrors, or maybe, lenses. So for lenses, I think in one section that I've asked, no, about what is their learning. Now they were talking about lenses that are diverging or converging lenses. No, so there are lenses that when light passes through them, no, instead of simply traveling in a straight path, they will tend to, no, collect at one point after passing the lenses. No? So we call that as a converging lens. No? So the light there is made to gather together. No? But there are kinds of lenses also that once light passes through them, then after passing or reaching the lens, they will try to, move away from each other, and we call it as a diverging kind of lens. No? So some versions of lenses, but it speaks about usually, about their shape. No? So some shapes of the lenses are concave, convex lenses. No? So similar to our mirrors as well. No? So kinds of mirrors that we have. No? And here's a principle of the law of reflection that we already mentioned. A picture of our specular reflection. So specular refers to the exact, image that you see. No? If you have a jar here, you will also see a jar on the other side. No? So it seems that the jar now, there are two jars that you are seeing, no? But one is, of course, an image. No? Then we have how these images are created. No? So if it is perceived by your eye, no? So of course this candle again, no, reflects its light, no, towards a plane mirror. So we have here, no, a candle that is kind of seen, no, by the eye. So you perceive it because there's a light that comes from the candle and strikes the surface of the mirror. Once it bounces, no, the light that bounces on the mirror is now reflected ray that goes to your eye. No? And that's the reason why you are seeing the object, no, not directly on your eye, but somehow, no, further away, similar in distance to the candle, no, from the plane mirror. No? So if you'll try to draw some kind of lines here, no? So we will notice that there is a line here. Now, if we will try to draw, so there's a distance here from the mirror to this lamp, no? And usually we call that as the object distance, no? From the other side, you'll also see another distance there. We call it as the image distance, no? So you have again, no? P, no? Usually P is the object distance. So it refers distance from the mirror, no? And then you also have here Q, and usually Q refers to the image distance from the mirror. No? Now, if you deal with a plane mirror here, no, then definitely, no, P must be equal to Q. No? The object there does not appear smaller or larger because again, no, the distance P and Q are most definitely, no, the same. No? Somehow in our drawing there, no, it seems that Q is a bit shorter, no? But in real life, in an actual, no, plane mirror, then they are the same. No? So this is your P and Q. No? And again, now that's the thing about images. Now the way we let now these lines of the reflected ray, no, pass through behind our mirror is by drawing this invisible line, no, or dash lines. So usually dash lines refers to an invisible line. So we extend it and we let it, no, cross a certain horizontal line there, and therefore you'll see the image, no, on their intersection. No? So we can actually call this now as the image. No? Okay, so that's with regards to a plane mirror. No? So if you are in a confined room again that is small, you will find the room to be wider. No? If you put mirrors, plane mirrors on the walls of the room. No? So you will be creating an illusion that the room is actually, no, wider than it is, no, because of the extension behind the mirror, no, that you kind of notice. No? So it allows, no, the creation of the room, no, a perception that it is wider. No? Okay, now moving on. No? So let me erase this because it will not really look good. No? So moving on, we have, no, the different types of mirrors created behind, no, or images created behind our mirror. Sometimes they are behind the mirror, sometimes they are in front of a mirror, of course. No? So if they are behind the mirror, we refer to the images as virtual images. No? And I think we've mentioned that one already. No? Okay, for our types of reflecting surfaces, we have spherical or plane mirrors. No? But for spherical mirrors, we can probably encounter two types, concave or convex mirror. No? And in the next slide, I think we've seen this one already. No? So I think I'm referring to this slide, by the way. No? So this is a convex mirror because the shiny part is on the left side. No? If you put an object on its left, you'll see it, no, kind of made smaller. No? Na doon nag-reduce siya. No? Okay. Now, when you deal with a concave mirror, so the shiny part is still on the left side. No? So it seems that it is no, the curving there, no, is covering the object in front. No? Now, going to the previous slide, no, there are points here that we will try to take note. No, like for example, the point called point C, which is the center of curvature. No? Point P, which is referring to the pole of the mirror. No? Or if it's a parabola, then that's the vertex of the parabola. No? And the line that is connecting this point C and point P, no? Which is known as the principal axis. No? So these lines, points, no, are somehow crucial, no, on how we understand, no, how light or images are formed, no, in front or maybe behind our mirror. No? So one main idea there that they always have, no, is the concept of, no, if you have a curved surface or a mirror. So for example, now let me draw a curved surface like this, no, and let's just cover the rest of that now with white. Sorry, should be. I'll draw white. Allow me to draw this. So let's say I have there now a concave mirror already. This red colored curved part, no? Or let me just redraw instead, no? Okay, so I'll draw another one. No? So let's say that's our mirror there, and let me cover the rest of that. No, I sorry. I'll cover half of it. No? So I'll just take a portion of the curve, no, or the sphere, and now I have here a curvature. No? Now if I'll trace a line here now somewhere in its center, no, so I can probably call a line here. No? I can call this line as my principal axis. No? Granting that, no, this is exactly, no, dividing this sphere into half. No? So that that axis, no, so this principal axis must pass through, no, 2 points. No? So the first point is the center of curvature, no, and this intersection point where the curve is made, which we usually call in parabola as vertex. No? So we call this as pole. No? We indicate it with the letter P. Sorry, that's just letter P, or V, no, vertex. And then we have another one here which we call as letter C. No? So this is our center of curvature. No? So the center of curvature is described as, no? So if you have a center and this is your circle, no? Then this must be a radius, no? If we are dealing with a circle. No? So this radius, when you make when you use a compass, no, to draw a circle, then you can complete this and make it actually, no, into an actual circle. No? But this is just a tiny portion of the radius, and this is its um, arc, I think. No, we call it as arc or curve. No, so again, no, halfway. No, if you will divide the radius into half, no, then what we will get is a point called the focus. No, so halfway na sa, no, halfway between the center and, no, and our radius. No, so no, vertex and our radius. No, so this we will call that as letter F. No, that's the foci, focus. No, and so ano na, no, C, F, and P. No, and therefore, no, when there is light here, no, that is beam, no, towards our mirror. So supposing naman yun, no, one principle about this light, no, that we beam towards the mirror. Sorry, no, na damage. So if we have there, no, kind of touch it, no. So again, let me just reconstruct some of this. So, manina. So, maniguro ato nyo na drawing kaina. No? So, again, sorry. Okay, so, na, no? If there's a light here, no, that we kind of beam, making beam to that being a light, no? And this light is probably, no, it looks like this one. So when it strikes the mirror, ang iyan nga kadtuan, no? So if this is parallel to the principal axis, no, the one that we draw below. Now this light will pass exactly, no, at the focus, no. So no, that's one thing about the light, no, that reflects. No? So this is the reflected ray, no. So this is the incident ray parallel to the axis. Once it reflects, no, from the surface of the mirror, it will pass through the focus. No? Now another light probably, no, that will be beamed, no, from our object. No? So granting that we draw here an object. No? So let's say ma-drawing ito sa object. Rin. So let's say that this object, no, is as big as this. No? So more already siya. No? Ang ini nga arrow nga isa ni, no? We call it as our object, no? Or maybe the person in front of the mirror. So isa ka light nag-agi sa iya ulo, strikes the mirror, bounces, no, to the focal point. No? Now, another possible source of light could be, no, na may ara kita nga light, no, that passes through, no, another light that passes through the focus. No? So halin sa iya ulo, nagbunggo siya sa mirror, no? And once nag-agi gani sa focus ang light, ang tendency sina is to be reflected na naman parallel to the surface, no? Parallel to the axis, I mean. No? So, kung parallel sa axis ang incident ray, mabunggo siya sa focus, but kung halin siya sa ang light halin kang nag-agi sa focus, ang iya reflection naman niya, no, parallel naman sa axis. Now, we'll notice that there is now an intersection point somewhere here, no, right around right after some center na to, no? And we call that, no, as, so let me just put a blue color here, no? Make my line a little bit larger. Now, we will now call this point, no, nga nag-intersect ang aton duha ka reflected ray as the image created. No? So the intersection of the two reflected rays eventually creates our image. So our image here, no, is not behind the mirror anymore, but, no, it is, no, it is formed, no, in front of the mirror. So the way we describe our image here, no, so the image could be probably described as, no, it's a real image, no? Then it is inverted, and somehow, no, it's a bit larger than the original image, so we call it as a magnified image. No? So nagsuli, no, so maybe, no, if you try to look, no, and this is you, no, looking at yourself is in front of the concave mirror, hindi mo maintindihan kung nga no, hindi mo picture out kung anong tsura sang tao da sa sulod kay galit sulit siya. So this is the case of a concave mirror. And, no, another point to mention is that the object, no, is standing in between. So this is between, no, the object is between C and F. No? So you can actually move yourself, no, at different locations. Pwede ka actually makakadto sa ibang nga location dali, no, sa sining diagram. So you can you can position yourself after the center, no, or, no, before the center. You can put yourself between center and focus, or you can put yourself between center and vertex or pole. Pwede man nga lapit-lapit tingin sa mirror, no? And maybe, no, the images that are created there will be of varied shapes, no, whether they are real or imaginary, no? But again, no, images created by our mirror. No? So this is one, no? Concave mirror naman ini. No? Now, what about kung may kita ginag-deal, no, na convex mirror? No? So let me erase this. No? If you're trying to look at, no, at our convex mirror, anong itsura sa ating convex mirror? So if we deal with our convex mirror, so if we have a convex mirror this time, no? So let's have a convex mirror. For our convex mirror, we will have the position of our convex mirror. Diri naman nag-aatubang aton nga so our mirror now, no, if we are standing, no, in front of it, so the curved part now is facing you. And maybe now we can cover the rest of that. So roughly now we have a small section of our mirror there. No? So that's our convex mirror now, and still, no, it has, no, the mirror still has, no, again, no, the mirror will have a principal axis gyapon. No? Again, when we talk about the principal axis, there is still the pole there or vertex. No? Now, allow me to call the point here now vertex instead. No? And maybe, you know, somewhere here you have a center. And in between them, no, you have a focal point. No? So, dapat equal ang distance ng B to F and F to C. No? So again, no, the center here is, pwede ka ka-drawing sang radius mo di. You have your focus, no, focal point, and your vertex or pole na kainag tawag natin letter P. No? Now you could let some object here, no, stand in front of our mirror. Pwede kita ka-drawing sang object karon in front of our mirror. Now again, no, one principle that we've learned, no, when we were talking earlier with our mirror is that it is a source of light. No? So whether it reflects light, but there must be some kind of a light that it is emitting. No? So once that strikes the convex mirror, now anything that is any light, no, that is always parallel to the principal axis. No? So the principal axis again is this bigger line that we draw earlier. So principal. Another principal axis. No? Now, once there's light that is striking, no, our mirror here, then it will always, no, reflect, no, in a direction that will pass through. No? It seems that it will pass through the focus. No? So kung mag-drawing ito sang line nga opposite ya, something na doon man eh, no? There must be some kind of a line that literally, no, passes the focus. No? So again, kung drawing ko natin eh, if you draw an extension of this, no, this extended line, no, will eventually, no, pass the focal point. No? Hindi siya malabay sa focal point. No? Now, another light probably that we could also encounter is the light that, no, will relatively, no, pass through the center. No? So diri naman siya sa center, dampi hindi siya ka-line kung sigihon tani mabunggo with siya sa center. No? So again, if you extend that, but of course since it's a mirror, then it will always stop somewhere here only. No? Now, the thing with the mirrors, guys, now when a certain light passes, no, through and going into, no, going into the center, ang iya reflection is that it will go back, no? It will pass back, no? Dili siya mabalik sa line, no? That still, no, passes the center. So dili na siya mabalik diretso, no? So question natin, how then can we create an intersection here? No? So of course, just like a while ago, what we did was create an extension. No? So if we create dashed lines here, imaginary lines, seemingly now will go towards our center. Damo ni ginadi ang aton nga extended line. No? Okay, now you'll notice now that we are able to create an image here. So an image is created roughly at this particular point. So the intersection of this reflected rays, a form of an extension, is that we created an image now that is small. So the image of convex mirror is that it is upright, it is standing up. However, it is reduced. Nagamay siya. It is reduced. But another important description is that it is behind the mirror, so we call it as a virtual. It's called as a virtual image. So again, things that describes our images that is in our mirror. So both for concave or convex, we can form these varied shapes of our images. Okay, do you have a question? Okay, so we go to our next slides. So anyway, we have that illustration now. So I am just simply sharing it to you. So we have there ways of how to understand our images. So moving on. So this is what we had a while ago. So how these lines are created again. When you have a line that is parallel to the principal axis, it will always pass through the focus. If there's also a light that is passing directly to the focus, the reflection will always be parallel to the axis. So again, the intersection here would always end up with an image eventually forming. So we have here an image that is between our center and our focus. Now another one is when you have an image here. So you can literally have a convex mirror. Now again, the intersections of the reflected rays are the ones that allows us to picture out where is the location of the image. Now to have the actual calculation of the distance of the images, we can actually use the mirror equation. And the mirror equation speaks about three quantities. Now, if you are dealing with spherical mirrors, so you have here 1 over P. So we add it to 1 over Q. And we divide it by, so equal to 1 over F. Now again, the values P, Q, and F are considered as your object distance. So we divide this. And you have the distance of the focus to the vertex, we call as focal length. So P again is referring to our object distance. Now the object distance is always measured from the mirror, mirror to the object. Then Q is your image distance. And F here is known as focal length. Now, one thing we remembered about the focal length is it is always 1/2. It is 1/2 of the radius. No? So if the radius is mentioned, all that you know is you can divide it by 2, no? To get the distance of the focal length. So the focal length is from the mirror to the focus. No? So that this distance is known as focal length. No? So the object, if this is the object, no? So if you're dealing there with the object, so the distance from the mirror to the object, this is called as letter P. No? That's the object distance. No? Mirror to object. Now, if there's an image here that we now draw, no? So if this is our image below, no? The image is inverted, no? As we described it earlier. Now the distance from no, the mirror to the object, so this yellow line, no, is known as Q. No? The red line is P. Q is your yellow line. No? Now, there's another length there again, we call as focal length. And focal length is this point. No? So this is the third line. So the focal length is from the vertex to P. No? To F, I mean. No? So this, the blue one is focal length. The red one is your distance, object distance, and Q is your image distance. No? Now, other things, or how do we know that there is magnification or reduction of images, is that there's also this value called M, no? Called as magnification. No? And magnification is a value that we can solve by dividing Q, I think that's Q over P. No? So therefore, now the ratio of Q divided by P gives you an idea whether the image is large or the image is smaller. No? So magnification principle. No? Okay, so any questions so far? No?